Welcome. We're going to look at 5.7. This is conjectures and proofs. So we're going to take some of these conjectures and we're going to prove them formally. And that's what it's saying here is now that we have additional knowledge about the angles formed when parallel lines are cut with a transversal, and we have criteria for convincing ourselves two triangles are congruent, side angle side, that type of thing, angle side angle, we can more formally prove some of these things about parallelograms. So given that you have a parallelogram ABCD, okay, a parallelogram again is opposite sides are parallel, right? And what we want to do is we want to be able to prove the statement that opposite sides are congruent. Okay, so that's saying that this side and this side are congruent, and this side and this side are congruent. We're trying to prove that. So we start with this triangle ABD. It's in green, and we're going to rotate it 180 degrees at point M, which is the midpoint of BD. Now once we have done that, then we will end up with this triangle BDC. And so therefore we have two congruent triangles after a 180 degree rotation. One of the things that we can say is we can say that the angle BDA, this angle right here, will coincide with the angle DBC. So those must be congruent. And that has to do with the fact that when you rotate 180 degrees, any segments that you have, such as this one, is going to be parallel to this one. Okay. The other thing we can do is we can say that DBA, so here's my DBA is going to be congruent to my BDC. Same type of thing. We've rotated it 180 degrees, that triangle, so therefore those angles coincide. Now, we've got congruent angles, and we also have the same side, BD, which is a shared side, so it must be congruent. So therefore, we can say that the two triangles, this ABD in green and the BDC in yellow, these triangles must be congruent because of angle side angle. It says side angle side. It should be angle side angle. Okay. Now, when we have two congruent triangles, then the corresponding parts must also be congruent. So one of the things we can say is that AB, which corresponds to DC, those opposite sides are congruent. We can also say that BAD and DCB, because it's the two congruent triangles, those angles are also congruent. And then there's another one that they're asking. It says, use the diagram to prove the statements that the diagonals of the bisect each other. So, for example, here's one diagonal AC and another one that is BD. So where these intersect, we are trying to show that they split into two parts. So again, let's start with triangle ABC. So here's my ABC. Actually, let me use a different color. That stands out a little bit more. So I start with my triangle ABC. And again, I'm going to rotate it at point M. All right. And by doing that, I end up with another triangle, which would be this one right over here. after rotating it at point M. Now, after rotating it, using the logic we had before, I can say that angle BAC, so let's use this, so BAC is going to have to be the same angle because it coincides with DCA. So now I'm saying that those two angles are congruent. In a similar way, I can rotate angle ABD. So this one might look like ABD. And once I've rotated that, I end up with BCD. And I'm rotating at 180 degrees on the midpoint. Remember, when you rotate 180 degrees, every line segment will be parallel with the image after rotation. So we can say things like this and this are going to be parallel, okay? Or this and this are going to end up being parallel. And that was what we learned with the parallelism, what happens when you rotate 180 degrees. So now, let me back this off. Okay, so now, given that we've done those rotations, we can also say that angle ABD, so here's my angle ABD, must be congruent to angle CDB. So we've got those angles that are congruent. We also have side AB and DC, okay, because if you are saying the angles are congruent and you're connecting these, that distance has to be the same. So now we can use side angle side to say that the green triangle must be congruent. Side, actually it's not side angle side, it's angle side angle. Let me fix that. So it's angle side angle, you can see in the diagram. Well, if we say that the two triangles are congruent, that means corresponding parts must also be congruent. So we can say, for example, AM therefore must be congruent to CM, and DM, because it's the same triangle, is congruent to MB. And that's corresponding parts of congruent triangles are congruent. So we have shown that the two diagonals have bisected each other.